image compression fidelity. The reconstructed image estimate f cap of x comma y equal to f of x comma y plus e comma x e of x comma y, where f of xy is the original image and e of xy is the error residuum after compression. The question is under discussion is how close is f of xy to f dash of xy. Assessment criteria for reconstruction fidelity. Subjective. Based on the human observer used in television, a cheap and a practical one equal to a different image. Objective. Calculated mathematically, the aim is to substitute subjective methods. Measurement of the compression loss. U1 to UN is the input sequence and U1 dash equal to UN dash is the lossy compressed sequence. Mean square error MSE equal to 1 divided by N I equal to 1 to N over summation of UI minus UI dash whole square. Single to noise SNR SNR 10 log 10 base 10 P2 divided by MSE whole square dV. P is the interval of impact sequence. Interval of input sequence values P maximum UN to UN minus minimum UN to UN. Measurement of the compression loss. Peak signal to noise ratio PSNR. PSNR equal to 10 to the power 10 m square divided by ms v square, where m is the maximal interval of input sequence value. Sample 256.8 bit arrange and where m is the maximal interval of input sequence values. Example 256 for 8 bit range and 665,356 for 16-bit range. SNR and PSNR are used mainly in applications. The expression for MSE serves as an auxiliary value for the SNR and PSNR definitions. Huffman coding. For the year 1952, input message that is symbols with the probability of the occurrence. Output optimally coded message. Prefix code that is no code word can be prefix of any other code word. It allows decoding without knowing the large of individual words corresponding coded symbols. Procedure. The binary Huffman tree is created in a bottom-up manner based on the probability symbols occurs. This tree serves for the message encoding. An integer number of bits per coded symbol. Let B be the average number of bits as per symbol. Let L be the average length of a coded word. H of V is less than or equal to L is less than or equal to HB, H of P plus 1. Huffman Coding example. Input message. Input messages are composed of 8 symbols with the known probability of occurrence S0, S1, S2, S3, S4, S5, S6, etc. 0.12, 0.26, 0.3, 0.15, 1, 0.03, 0.2, 0.2, 0.02. Same here, 0.02. S1, S1, S2, S1, S3, S0, S4, S5, S6, S7. 0.3, 0.26, 1.5, 0.15, 0.12, 0.01, 0.03, 0.02, 0.02. Huffman coding example. Huffman coding example. Input messages are composed of 8 symbols with a known probability of occurrence. Huffman coding examples. The message input messages are composed of 8 symbols with a known probability of occurrence. S0 to S7, 0.12, 0.26, 0.3, 0.15, 0.1, 0.03, 0.02, 0.02. S2, 0.3, maximum 1. The next maximum S1, 0.026. Then less than above point S3, 0.015. S2, S1, S3, S0, 0.12, and then 0.15, S4, S5, 0.2, no, this one. This one 0.04. Often coding example. Input messages are composed of 8 symbols with the known probability of occurrence. S0, S1, S2, S3, S4, S5, S6, S7. S2, 103. Then which one is this one? S1. Then 0.15, 0.12, 0.02, 0.03. And then 0.2, this one 0.02, 0.04. Then among these 0.07. Input messages are composed of 8 symbols with the known probability of occurrence. S2, 0.3, S1, 0.026, 0.15, 0.12, yes, 0.01, 0.03, 0.02, 0.02. So common 0.04, common 0.07, common 0.17. Huffman coding example. Here, input messages are composed of 8 symbols with a known probability occurrence. S0 to S7. Here, S3 is the point 0.03. S1 is the 0.026, and then 0.15 S3, 0.12 S0, common 0.027, 0.1 from S4, 0.03 S5, 0.02 here. Here to save the Huffman coding, add with this, then add with this, then 0.017 available. Huffman coding example: input messages are composed of 8 symbols with the known probability of occurrence. Messages are composed of 8 symbols with known probability of occurrence. 0.3. 0.26, 0.15, and then 0.12, and then 0.1 S4, 0.3 S5, S6, S7, common, 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 0.4. Huffman coding example: input messages are composed of 8 symbols with a known probability of occurrence. Here S0, S2, 0.26, and 0.15, 0.2, 0.12, 0.1, 0.03, 0.02, and 0.2. Huffman coding example: input messages are composed of 8 symbols with a known probability occurrence. 0.03, 0.026, 0.15, here 0.1, 0.03, 0.02, 0.02. Okay. Huffman coding example: reordering of the tree. Reordering is needed to have the tree without crossing branches. Coding either 0 or 1 at the branching points. Here, start then coding and tree coding. So 4, 0, 2, 1, 1. Compression of segmented interpreted image data. Same methods can be used for binary images because they can be treated as a result of segmentation. Once in the image correspond to objects and zeros to background or vice versa. Taxonomy of methods. Chain code representation of a region boundary, a special case of the polygonal representation. Lossless compression. Region boundary approximation by a